Hello students, welcome to maths class. So today we are going to start a new topic, conic section, right? So conic section means, conic means cone, section means cutting. So if we cut the cone with different angles, we will get different shapes, that is called conic section. So today we are dealing this conic section. Okay, once again, conic means cone, section means cutting. So if we cut the cone with a plane with a different angles, right, we will get different shapes. Okay, so those shapes are called conic section. So we are going to get three shapes. One is parabola, second one is ellipse, and the third one is hyperbola. Okay, so first, what is meant by conic? How we can define a conic? Means conic is nothing but a curve made by a point, So this point can be on any curve, either it is on parabola or ellipse or hyperbola. Okay, so this point on a plane moves in such form that its distances from a fixed point and a fixed line is a constant ratio. That ratio is called E, right, and it is called eccentricity. Once again, conic is nothing but a curve made by a point, locus, right. In first year you gone through the locus, all curves are nothing but locus made by a point, I said. So here also curve made by a point. In this conic, this point satisfies one geometrical condition. What is that geometrical condition? Means this point maintains a constant ratio of the distances from a fixed point and fixed line. Okay, so SP by PM is equal to 1. We can write SP by PM, right, is equal to E. That constant ratio is called E, right. If E is equal to 1, it is parabola, right. This E is called eccentricity. Okay, so SP by PM. Okay, so that value, it always maintains a constant. This point maintains a constant ratio of the distances. Distance of P from S and distance of P from M, they will maintain a constant ratio. That ratio is called eccentricity, right. If E is equal to 1, it is called parabola. If E value is greater than 0, less than 1, then it is ellipse. And if E is greater than 1, the conic is called hyperbola. Conic is nothing but cutting of a cone with different angles. So how we can define those curves? After cutting, we will get three curves, three shapes. One is parabola, second one is ellipse, and third one is hyperbola. Okay, so here how we can define this conic section? Means nothing but a curve made by a point. And what is the condition satisfied by this point? Means this point maintains a constant ratio of the distances, constant ratio of the distances from a fixed point and fixed line, right. So it is SP by PM, right. That is called the constant ratio, and it is called eccentricity. It is called eccentricity and denoted by the letter E, right. If E is equal to 1, the shape is parabola. If E is less than 1, greater than 0, the curve is ellipse. And if E is greater than 1, the curve is hyperbola. Okay, so today we are dealing the topic parabola. We are having all the three topics, right. Parabola is there, ellipse is there, hyperbola is there. So today we will start our parabola equation. So first come to the standard form of parabola equation. If you observe, this is called the parabola curve. So it is a symmetrical curve. Symmetrical curve means the area above the x-axis and below the x-axis will be same. That is called the parabola. Symmetrical means the area above the axis, below the axis will be same. Parabola is a symmetrical curve, and you know that here this fixed point is called the focus. Here fixed point, I said fixed point and fixed line, isn't it? So this fixed point is called focus, right, and fixed line is called directrix. So here SA comma 0 is the focus, right, and L is the directrix of the given parabola, okay, and A is called the vertex, right, A is called the vertex. So we are giving the standard form of parabola equation. So here we will write first, let SA comma 0 is the focus, right, is the focus, right, focus, and directrix also you have to give, and directrix equation, and L is equal to x plus A is called is directrix of the parabola, directrix of parabola, okay. So this is your description. S is the focus and L is the, this is your directrix. Exactly from here to here the distance is A, here also the distance is A, okay. So A to S the distance is A, and A to Z the distance is A, okay, is a directrix of parabola, okay, and we can write A is the vertex. So A 0 comma 0 is the vertex of the parabola, vertex, right, of parabola. So these are the descriptions. So from parabola, in this parabola, from vertex to S and from vertex to Z the distance is same. So actually this line is x is equal to minus A. So we can write x plus A is equal to 0 is the directrix equation, okay. This is the description of your parabola. Now we have to derive the standard form of parabola equation. How we can derive? So you take one point, let P x comma y be a point on parabola, okay, parabola. So what happened? By definition, what is the geometrical condition? By definition, it is SP by PM is equal to 1, okay. By the definition, SP by PM is equal to 1. The point maintains a constant ratio of the distances from a fixed point and fixed line, right. So that fixed point is called focus and fixed line is called directrix, okay. So it is SP is equal to PM, okay. What is SP? SP is the distance between S and P, and what is PM? PM is the perpendicular distance from the point to the directrix, or here also, that is also conic, right. So this is nothing but the perpendicular distance. Here we will write M, right. So perpendicular distance here, your M, perpendicular distance from P x comma y to the line directrix, okay. So this is nothing but SP is equal to PM means perpendicular distance, right, from which point? P x comma y to which line? Come on, what is that line? X plus A is equal to 0, okay. So come on, what is this? The distance between 2 points, you know the formula, root of x2 minus x1 whole square plus y2 minus y1 whole square. So your one point is x comma y, another point is A comma 0. I said, isn't it? Focus is a comma 0. So it is x minus a whole square plus y minus 0 whole square is equal to perpendicular distance formula. You know it, modulus of ax naught plus by naught plus c by root of a square plus b square. Here a means 1 into x plus b term, y term is not there, 0, right, and constant is a. Right, so it is modulus of 1 into x naught, y naught is x comma y. From the point P we are taking, this is conic, this is parabola, right. From x comma y we have to take the perpendicular distance to the directrix, right. So it is 1 into x plus no term of right y term, so it is a constant by root of x coefficient whole square plus y coefficient is we are having 0, right. Now squaring on both sides, okay, squaring on both sides, what happens, square root will get cancel. So x minus a whole square plus y square is equal to modulus of x plus a by root 1 is 1 only, square root cancel and 1, no need to write anything by 1, okay. If you want to write, you can write, right, x plus a. Squaring on both sides means here also square, here also square, right. Here squaring on both sides, square root will get cancel. So what happens, expand it, a minus b whole square form, x square plus a square minus 2ax plus y square is equal to, come on, x square plus a square plus 2ax, okay. So x square cancel, a square cancel, send this minus 2ax that side, then you will get your y square is equal to 2ax plus 2ax is equal to 4ax. So y square is equal to 4ax is the standard parabola equation, okay. So once again listen carefully, today we started the topic parabola. So it is one part of conic section. So what is meant by conic section means, if we, section means cutting, if we cut the cone with different angles, right, we'll get different shapes. Mainly we are having 3 shapes, one is parabola and second one is ellipse and third one is hyperbola, okay. So cutting the cone is called conic section. So we are dealing now with the conic section. In this conic section you are having 3 topics, right, parabola, ellipse, hyperbola, right. So today we are dealing with parabola. It is a 9 marks topic, 1 7 marks question, 1 2 marks question. Now come to the definition of conic. Conic means it is nothing but curve made by a point. Conic is nothing but curve made by a point which moves in such a form that, or which maintains the constant ratio of the distances from a fixed point and fixed line. That fixed point is called the focus and fixed line is called the directrix, okay. So that ratio is called eccentricity and it is denoted by E. That ratio is called eccentricity and that is denoted by small letter e. If e is equal to 1, it is parabola. If e is greater than 0, less than 1, it is called, that curve is called ellipse, and if e is greater than 1, the curve is called hyperbola. Okay, so after that we derived standard equation of the parabola. So this is the diagram of your parabola. Observe, so it is a symmetrical diagram. That means the area above the axis must be same as the area below the axis. Then that curve is called symmetrical curve. So any curve which maintains the area area above the axis, below the axis equal is called symmetrical diagram. Your parabola is a symmetrical diagram. Okay, so in this parabola, this is called the focus, right? SA comma 0 is the focus, and this line is called directrix. So if we take any point on the parabola, on the curve, it always maintains a constant ratio with the distances of fixed point and fixed line. Fixed point is called focus and fixed line is called directrix. Okay, and focus is denoted by the letter capital S and directrix is denoted by the letter small l. Okay, and this is called the vertex of the parabola. That means nothing but 0 comma 0 origin, isn't it? Point of intersection of x-axis and y-axis, isn't it? Point of intersection of x-axis and y-axis, that is called the vertex of the parabola. Okay, so from this A, the distance to this focus is equal to the distance to the directrix. That means this distance is A, means this distance also A. That is the description of your parabola curve. Okay, so let us A comma 0 is the focus and L is equal to x plus A. Actually, if we take this directrix is left side of your y-axis, so we can write this as x is equal to minus A and bring that minus A this side, it will be x plus A is equal to 0, right? That is your directrix equation. So next A0 comma 0 is the vertex of parabola. A0 comma 0 is the vertex of the parabola. Now you take one point Px comma y be a point on the parabola, and you know that if we take any point on the parabola, by the definition of conic, right, SP by PM is equal to E, and if E is equal to 1, it is parabola. So SP by PM is equal to 1 and SP is equal to sending PM that side, SP is equal to PM. Okay, and what is SP? SP is nothing but the distance between S and P, and PM is nothing but the perpendicular distance from P x comma y to the directrix x plus A is equal to 0. Okay, so SP means the distance between 2 points, means always we will take the formula root of x2 minus x1 whole square plus y2 minus y1 whole square form. So here one point P is x comma y, another point S is A comma 0. So x minus A whole square plus y minus 0 whole square is equal to perpendicular distance from P to the line directrix, right? So what is your P x comma y, and what is your line? Line is, what is that line? X plus A is equal to 0. Okay, so perpendicular distance formula is modulus of A x naught plus B y naught plus C by root of A square plus B square form. So where A is 1 into x, B is 0, 0 into y, and constant is A. So that's why here x naught y naught place we are having the x comma y. So 1 into x plus 0 into y, no need to write, plus A by root of x coefficient whole square plus y coefficient whole square. X coefficient whole square is 1 square, y coefficient whole square is 0 square. Okay, so next squaring on both sides, just squaring on both sides, your square root will get cancel, square and square root, and this side we have to do the square. Okay, A minus B whole square form, A square plus B square minus 2AB, and this is y minus 0 whole square means y square, and this is A plus B whole square, A square plus B square plus 2AB, x square cancel, A square cancel, send your minus 2AX that side, y square is equal to 2AX plus 2AX 4AX, so y square is equal to 4AX is the standard parabola equation. Okay, so how this is most important 7 marks question, derive standard parabola equation. How we derived? By taking the geometrical condition. Generally locus equation, how we proved a locus equation, we will consider one point on that curve, then we have taken the geometrical condition, right. Geometrical condition is SP by PM is equal to 1, right. So then we selected some appropriate formula to convert that geometrical condition into algebraic form. At the end, the equation must be in terms of x and y. Same thing we did here. Okay. So here geometrical condition is SP by PM is equal to 1. Okay. So very simple conic section, we are having three parts, right. One is parabola, second one is ellipse, and third one is hyperbola. Conic section means cutting the cone with different angles, we will get different shapes, right. So in that, one is parabola, second one is ellipse, and third one is hyperbola. Okay. So now we are dealing with a parabola. So it depends on E, the ratio, right. If E is equal to 1, that curve is called parabola. If E is less than 1, it is ellipse, and if E is greater than 1, it is hyperbola. So we have taken that SP by PM is equal to E, where E is equal to 1, Y, we have taken parabola here. Okay. So very simple derivation, right. We derived the standard parabola equation. Very important 7 marks question. Compulsory you have to draw the diagram. So we are dealing with B paper geometry. So we have to take the support of the diagram. So here this is your focus A comma 0, and this is your directrix, right, and we will take one point on the curve, right. From that point you join the right lines to the fixed point focus and fixed line directrix. So SP by PM is equal to 1 by definition of parabola. We have taken that one and we proved the that means equation of the parabola. Okay. So that's all for today. Have a nice day.